Hello. Today we're going to work on solving for a variable. So I have an equation here, 5 times the quantity x minus 3, closed quantity, plus 7 equals 3x plus 10. Now, when we say solve for the variable, our goal is to get the variable by itself. So we're going to start in our very traditional way. We see some parentheses and we're going to deal with it. Well, x minus 3 itself isn't something I can do. I can't combine x and 3. I don't know what x even is in order to be able to subtract 3 from it. But knowing that I have 5 times that, I do have a way around this. And that is, I can distribute. I can send the 5 to the x and the 5 to the negative 3. So 5 times x gets me 5x. 5 times negative 3 is minus 15. Okay, so again, I just distributed. I multiplied the 5 to both the x and the negative 3. Now, we still have the plus 7 at the end of that equals the 3x plus 10. But just to tell you what I did here, my first step was to distribute. Okay, let's continue on. I see here on the left side that I have a negative 15 and a positive 7. They're on the same side, so all it's asking me to do is negative 15 plus 7. Now, I know that negative 15 plus 7 is negative 8. So I can change that out. I can change negative 15 plus 7 into negative 8. So we still have 5x. But now it becomes minus 8, still equals 3x plus 10. And what let me do that? What let me replace negative 15 plus 7? Anytime we do replacement, that is called substitution. Right, we replace one thing with something we know it's the exact same as. So that's substitution. Okay, now I have x's on both sides of the equation here. So I'm going to move all of my x's onto one side, right? Our goal is to get x by itself. So in order to get x by itself, I should really only have the one x value variable. And the easiest way to do this, knowing that 3 is smaller than 5, as far as 3x and 5x go, I'm going to move the 3x over. It's a positive 3x, so I'm going to move it by subtracting. So I can write my reason here, and that is subtract 3x. And whatever I do on one side of an equal sign, have to do on the other. Okay, our result is 5x minus 3x is 2x. That minus 8 is still there, equals. The 3x minus 3x is gone. Those cancel. That was the whole point of it. We wanted it to go away. And then we have a positive 10 at the end here. Okay? Again, what allows me to change 5x minus 3x into 2x? Anytime we did replacement, like we just did, that is, again, substitution. All right, continuing on. Reminding us that our goal is to get x by itself. We have two things still happening to x. We are multiplying by the 2, and we are subtracting by 8. And we want to get x by itself. We want to undo the order of operations here, which means I'm going to move that 8 first. And the opposite of negative 8 is a plus 8. And I'm going to do that on both sides. So plus 8 on both sides. And we end up with the 2x. These cancel like they were supposed to this whole time. I'm sorry, I don't know if I said that right. It was 2x. Those cancel. We have an equal sign. And then 10 plus 8 is 18. And so what did we do? We did addition. We added 8 on both sides. And this is probably going to sound redundant, but what allowed us to change 10 plus 8 into 18? It's the exact same thing that we've done every time. It's substitution. Again, we're replacing 10 plus 8 with 18. Now, our final step here, we have 2 times some number equals 18. Well, 2 times x, well, how do we get x alone? How do we undo times 2? We're going to divide by 2. I'll even write that over here right away before I forget. Divide 2. So 2 divided by 2 becomes 1, just like we wanted. So we have x equals, and then 18 divided by 2 makes 9. And what allowed us to change 18 minus 2 into 9? Hopefully you guessed it here, substitution. Okay, this is the basic order in which you're going to solve any equation. If there's some sort of distribution, you're going to do that piece first. Then, this is what we typically call, you may have heard it as, combine like terms. Anytime you do one of these operations, distribute, add, subtract, multiply, divide, you're going to follow it up by doing any combine like terms that you can. So then we subtracted to get all of our variables onto one side, combine like terms. There it is. We added 8, combine like terms. Divide by 2, combine like terms. Okay? Now before we finish up here, how can we check to make sure that 9 is actually the right answer? Well, let's go way back to the top and we'll put 9 in and see if it works. So instead of x, I'm going to substitute in 9. So 5 times 9 minus 3 plus the 7 equals 3 times 9 plus 10. I want to see if these are equal to each other. Well, parentheses first, so no, 9 minus 3 becomes 6. So we have 5 times 6 plus 7 equals still 3 times 9 plus 10. Order of operations lets me do multiplication next. So 5 times 6 is 30, adding 7 to that. 3 times 9 is 27, adding 10 to that. And we get a result of 37 on the left and 37 on the right. They're the same thing, so x must indeed be 9 in order to make this a true statement. Okay, we are done.